Hello, welcome. Today we're going to talk about the shape of the Earth in outer space, our Earth science class. The Earth is not flat. I do not care what websites you show me this year. I do not care what websites you find and how convincing they are. They are wrong. The Earth is a sphere, period. Right? The satellites that are out floating around the Earth right now that allow for the internet to work the way it does and our phones to work the way they do prove that the Earth is round. Right? The people that go on the internet to find proof that the Earth is flat is kind of silly because you wouldn't have the communications and the internet that we do without satellites floating around our round Earth. Okay? We have photographic evidence, videos from the International Space Station, photos from other satellites. The Earth is round. I will post a video of Alex Baumgartner jumping from the outer reaches of our atmosphere, and you can see the Earth's curve. Okay? However, the Earth is not perfect. It looks perfect. And if on any state exam it says what's the best choice to represent a model of the Earth, you go with whatever is the roundest, smoothest object. Usually it's a ping pong ball or a table tennis ball. Okay? They'll try to trick you with something like a football because it's got that oblong shape, and and it's a little bulgy at one, obviously at the equator. That's not right. They'll try to trick you with a basketball because you're going to say, oh, well, the basketball's got bumps, it's got ridges on it. So like the Earth has valleys and mountains. But remember, the Earth is perfectly smooth if you look at it from outer space, because above every mountain and every valley is this giant atmosphere of air, right? The gas layer, right, that makes it smooth. So please recognize that the Earth is not perfect, but it looks perfect and is almost perfect. So any question about the shape of the Earth, the answer is going to be it's an oblate spheroid, which means a little bulge. But the best model is going to be a perfectly round, smooth object like a table tennis ball, a ping pong ball. The other important lesson from today about the shape of the Earth is that the Earth is a sphere and it has gravity. Okay? At the center, gravity is pulling everything towards Earth. It's how our layers of the Earth form. It's what holds us on so we don't fall off. It's why people can be on the bottom of the Earth and not fall off, because gravity is still pulling them towards the center of the Earth. It's why the moon goes around us, because gravity is pulling the moon around us. It's not just floating off in outer space. And the largest object in our solar system, mass-wise, is 100% the sun. And that's why everything goes around the sun, because the gravity of the sun is so strong. Okay. Back to the idea of the shape of the Earth. The oblate spheroid, remember, it's slightly bulged at the equator. So it's like if I took a ball and squished it, you can almost see how it flattens out in this direction. So it's slightly fat at the equator. Again, so small you can't tell the difference. So remember these key takeaways from today. The Earth is a perfect sphere when you are doing a model. So you would take a ping pong ball because it's perfectly round and perfectly smooth. The Earth's true shape, however, is slightly imperfect. It's an oblate spheroid. That just means it's a little fatter at the equator. And gravity is just what is pulling and holding the Earth together and holding us onto the Earth. And the two things about gravity we learned are the larger the object, the more mass it has, the more gravity it has. And the further away objects are, the less gravity pulls on them. That's it. Have a great day.